expanding and factorising perfect squares. So remember, a perfect square is just a number that we know if we square root it, we get a nice number. But here we're going to look at it in terms of algebra and quadratics. So what does it mean to have a perfect square when we talk about quadratics? Well, a perfect square might look something like this. X plus 2 all squared, because when we go ahead and square root this, we know we get something nice because the square root and the squares cancel out and we get just x plus 2 here. So how would we go about expanding a perfect square? Well, with this one, x plus 2 all squared, we could rewrite it as x plus 2 times x plus 2. And we could go ahead and expand it out as we normally would. X times x is x squared, and x times 2 is 2x, positive 2x, and then this 2 times x is positive 2x, and this 2 times this 2 is 4, but I might write it as 2 squared for now because it's 2 times 2. And we can simplify this, but not going to just yet. Let's just have a look at x plus 3 all squared. We can rewrite this as x plus 3 times x plus 3. And we'll get x times x is x squared, and x times 3 is 3x, and 3 times x is 3x, and 3 times 3 is 3 squared. And hopefully you can see a bit of a pattern here. Because we're multiplying the same thing with each other, we end up doubling up our terms in the middle, 2x and 2x, and 3x and 3x. And because this numbers are the same at the end, because it's squared, we just end up getting that number squared. So what ends up happening when we simplify, we get x squared plus 4x plus 4. And this one we get x squared plus 6x plus 9. And we can actually develop a little bit of a shortcut here, because we know every time that we're squaring the first term, we're timesing these two together and then doubling it. So x times 2 is 2x, double that is 4x, and then we're squaring that last term. 2 squared is 4, and it works the same here. Square the first term, x squared, times these two together, 3x, double it, 6x, square that last term is 9. So we actually, if you would like, we can write a formula generalizing these results. We can say that a plus b all squared, well, we square the first term, so we get a squared. We times the two together, a times b is ab, then double it, get 2ab, and we square the last term, where we get b squared. If it happened to be a minus in the middle, a minus b squared, we just do the same thing. We square the first term, a squared, we double the product, so a times minus b is minus ab, double minus ab is minus 2ab, and we square the last term, minus b times minus b is plus b squared, because a negative times a negative is a positive. And we can use those to easily expand a perfect square. But I like just memorizing it in words, so like square the first, double the product, and square the second term. So that's expanding, but how are we going to be able to go the other way and factorize? Let's have a look at x squared plus 10x plus 25. How are we going to look at maybe factorizing this? Now we know it's a quadratic because we have an x squared term, and the way we're going to know if we can factorize this as a perfect square is if we can take the constant term, which is 25, and square root it, which gives us 5. Then if you double 5, you get 10. And if that number matches this number, we know it's a perfect square. Which means that to factorize this, we just write it as x something all squared. But what do we need to put there? And the thing we need to put there is whatever this number was, whatever the square root of the constant term was. In this case, it happens to be 5. And this sign here in front of the x term will determine the sign over here as well. Let's have a look at another example. X squared minus 14x plus 49. Again, let's do a check. Let's check the square root of 49. Well, that's 7. And if you times 7 by 2, you get 14. And that matches up with what's in front of the x here. So this means we can write it as x something all squared. And what do we need? We need to put 7 there. What sign do we put? That's dependent on the sign in front of this x term. So it's negative. So we get x minus 7 all squared. And if you weren't sure, you could even expand it out. Squaring the first term is x squared. Doubling the product, well, the product's minus 7x, doubled it, you get minus 14x. And squaring the last term, 7 squared, minus 7 squared is plus 49. Let's have a look at another example. So we have 25 y squared plus 100 y plus 100. So this isn't looking as nice because the numbers are a lot bigger, but more importantly, the term in front of the coefficient in front of the squared term is not 1. So here, it doesn't have to be 1, but it might make things a bit easier here if we factorize out the 25 first. So let's do that. And we're left with y squared plus 4y plus 4. And then now in here, we can even check if we have a perfect square. So if we square root that, we get 2. And if we double 2, we get 4. So it works out nicely. That means we can rewrite it. It's 25 outside of y, all squared. And we know that number we need is 2. And the sign in front of the y term is positive. So we get that as our final answer for the factorization.